to understand why is versioning important. What is versioning and why is it important? Yes, why is versioning important? That's what we are going to learn now. So let's suppose you're working on some documentation or code that you are regularly updating or updating regularly. And you are using S3 bucket with versioning enabled to store the files. For example, this is the file that you have stored on the S3 bucket. And when you upload the file to S3, AWS actually creates a version of that file. Let's suppose the version is version 1. You went on updating the file again and you uploaded it again, and thus version 2 of the file was created. Here version 2 is an update to the version 1 file. This means the older file has the old content and the version 2 has the latest changes. Similarly, you updated the document and uploaded it a couple of more times, and version 3 and version 4 were created. And thus the version 4 that you see, which was created just now, is now the latest version of the file. And I'll ask you one thing. So here, if you were to pull the latest file, you will get the main file. That is the latest version of the file, isn't it? That you have updated most recently. Now what would happen if the main version of the file had some issues and you don't have any other working copy with you? Let's suppose it was an important presentation and you unintentionally deleted some slides before uploading the file. What would you do then if there was no versioning and you did not have any other working copy of your file? After giving it a thought, you recall that the older files were completely fine and you could use one of them to get things done, and you realize that you still have the working copy of the files that are version 2 and version 3, and thus you are saved. Now tell me, what would happen if you didn't have versioning or if you didn't have a copy of the working files with you? You would be in a huge problem, isn't it? And I'll ask you again, do you now understand the importance of versioning? Okay, now let us come back to a similar situation. You are a developer and you have your source code for your application or project or whatever you're working on. And let's suppose each change you make, I'm not saying like one variable change or a file change or addition, it could be anything. Let's suppose, or let us for example think of each change to be a set of modifications of the code made to the code, like a set of changes, a set of modifications. Here we have the changes listed, like change 1 is adding comments, change 2 add feature implementation, change 3 correct regression test changes, change 4 add variable declaration, change 5 is bug fix, and change 6 is initial changes for source code. So the list of changes that you see here is basically called your historical source code changes, because it lists out the historical changes. Historical change actually simply refers to the changing of events or the changes to the events over a course of time. Here the events are basically the changes that you have made to your source code. So these are your historical changes. Now let us take these changes that are the historical data sets of the changes that you have made on your source code, and imagine your team is working on the main source code along with you. Now imagine that your team is also working with you on the main source code and they have a subset of the changes that you have made when you shared your code with them. And remember, we still don't have a mechanism in place to share the code seamlessly. This is just hypothetical. I'm just giving you a scenario. So these were the current changes that everyone has, and these were the current changes that went along with the main source code, and these are the changes that you have done after you shared your code. So these will be called your new changes. And now we can see that these new changes are not yet available to anyone else in your team. This is a very complicated situation, isn't it? You would agree on this with me? Think of this and try to relate to a scenario where you are not sure if you have the latest code. How would it be? One of the main team members that you're working on with has the updated changes, but you don't. Now that we are in this situation, Sam wants to share the code that he has for himself, or he has with himself, the new changes with his teammates. Because he feels like he has the updated code and he thinks they don't have it, so I should share it. And Sam here felt that what would happen if we had a server or a repository common to everyone, where Sam can actually store and retrieve the code. And so the other teams as well can do the same. So this placeholder for the code will be our server or repository. And this is the place where everyone can store the code and retrieve it from as well. So this placeholder that we have is like a gift to us, where we can actually store our code, and this would be great, isn't it? But wait, let's not jump the gun as yet. So if we think rationally, there would be a lot of questions that would be running in our minds if we think of this common server approach. Common server in the sense like everyone has access to the same server and everyone has the rights to actually store the file or retrieve the file. The first and a very important point that would come into our mind is, think about what would happen if you store the code which updates the changes made by others. It would override the changes, isn't it? How will you store your changes separately so that you can keep working without affecting the changes made by others? Or even how can you retrieve just the set of changes that you want for your feature implementation? And the next one is also very important. How can you ensure that your changes can be reviewed before being stored on the server? Who is going to review it? How are we going to review it? And the next one is also very important. That is, how can you ensure that you get the latest changes from the server? And all these questions are valid questions, isn't it? But do we have the answer to these questions? As of now, we don't, but we will. Keep watching. So what could be the solution? So now let's bring our developers and the admin and our team members that we have working on the application. So don't worry, this is like you and me are also part of this one. So even if I am the admin, you could be one of the developers. So that's a very good thing here. So watch this, it's very interesting. And here we have a server or repository. So there's the common server that we were talking about. But the interesting part here is we are going to design this server in a special way by adding some conditions and constraints, and we'll see how it works. So the first thing that happens is the initial code gets updated on the server by the admin or the developer. Then the other team members actually pull the code to get the code from the server itself. So we are good, isn't it? This looks very good because first the team member or the admin has uploaded the code or updated the code, and the other team members are able to access it and they have the code with them. Now everyone has the latest code with them. The next thing that happens is a couple of developers have made changes to the code. Let's see if the server can handle this situation. Here, one of the developer actually sends the changes to the server. Let's assume that it would send the whole updated source code that he has worked on. Now, as the server has a condition with it to compare if there have been any new changes already stored in the server, it does the comparison. As this is the most recent change that has come to the server actually accepts the change and sends the response that your changes are updated. So this is a good thing, isn't it? The developer has stored the changes and he has received the message from the server that the changes are updated. And now the server has code that already has some changes. Let's see what happens when the other team member tries to upload the source code to the server. Oops. Okay. So we have got a response from the server. It says there are existing changes made to the code. Please retrieve them before storing the new changes. Okay. The developer actually takes the changes in, makes the update, and now the server is fine with the changes being made. And it sends the message back as changes updated. Have we solved the problem yet? So let's check this again and let's reflect on the approach. Everyone has the latest code or the latest copy of the code, but if and when they have any change and they want to update the code on the server, they have to update and commit if there are any changes to the code already available on the server. Yes, they have to first update it, and then only they can commit the changes to the server. And you obviously would be thinking this approach is something that I have come up with. Obviously not. We already have this solution available to us, and that is basically the centralized version control system. And when we talk about centralized version control system, in this approach, the server that you see here acts as the main repository that stores every version of the code. Here, every user that you have commits directly to the main branch, and this type of version control works well with teams with small numbers or smaller teams, because team members have the ability to communicate quickly so that no two developers want to work on the same piece of code simultaneously. And hence, strong communication and collaborations are important to ensure a centralized workflow and the success of centralized workflow. And this approach enables file locking so that any piece of code that's currently checked out will not be accessible to others. So what does it mean? It means that it will ensure that only one developer can contribute to the code at a given point of time. And this is called centralized version control system. And here I have used two terms. One is update and the other one is commit. These might be new for you if you haven't used Git before, but don't worry about them. For now, just listen to what I'm saying. So update is when you take all the code that you have in your repository and you apply them in your working directory or the working copy. And commit, on the other way around, is when you take all the changes that you have made in your working directory and apply them into the repository. So this is a centralized version control system because your actions are centralized to a single unit of work, that is your server repository, and everyone working along with you is basically accessing the same place. So update is when you take all the code that is in your repository or the main server that you have and you apply them in your working directory or the working copy. And commit is when you take all the changes that you have made in your working directory and you apply them to the server. So that is why when the user actually was trying to update the code or commit the code, it had to take the updates first because the server was not allowing it because there were already new changes in the server. So then it had to update the code and then only it was able to commit the new changes. And that is CVCS, which is Centralized Version Control System. And I'm sure that you have heard of these names before, and I would like to present to you some of the most popular centralized version control systems like CVS, Subversion, and Perforce. So that was about centralized version control, but Git is distributed, and that is important to us because Git is an open source distributed version control system. So what is the difference? So this is CVCS. Let's change things here. And let us place a server repository for each of the developers. Yes, let's give each of the team members a local server of their own, along with the main server, which is located remotely on the cloud itself. Now you see the difference? We have placed a local server to each of the team members, and we have a server which sits remotely on the cloud. And now each team member can work on their own code individually without worrying about other making changes, and they can commit or replace the code they want in their own local server repository. This is beautiful, isn't it? And each local server syncs up changes to and from the remote repository so that even though you want to make changes, you don't have to work on the main server directly. And the local server will perform the pull and push of the changes made to the code by you or from the remote server itself. This is very interesting, isn't it? And this approach is called decentralized version control or distributed version control. In other words, distributed version control system. And if you read the definition of DVCS, it says that in software development, distributed version control, or also known as distributed revision control, is a form of version control in which the complete code base, including its full history, is mirrored on every developer's computer. You see the reference here? It is mirrored on every developer's computer, the one who is using it, obviously. And all the developers that you see here can work on the code, make changes, and commit the code in their local server without affecting anyone else and anyone else's changes. And when you're done, you can perform a push action to send your code to the remote server just like others. And you can perform a pull if you want to update your local server repository with the latest changes from the remote server. And one of the most popular distributed version control system is Git, and the other one would be Mercurial. And I'm sure most of you have heard of them, or you might have used it, or you might be trying to learn about them. So I'm happy that we are talking about this. And if you have liked the content so far, please do like the video. Please make sure you subscribe. It helps the channel grow and it's free. So please do subscribe and like the video. Let's move on. Now let's see what are the differences between CVCS and DVCS. You might be thinking, why am I talking so deeply onto this topic? It's because until and unless you know what you're using, you will never be able to use it to its full potential. And whatever you learn, you should learn it completely, isn't it? So let's start off with CVCS, that is Centralized Version Control System. Here, this is based on a server client architecture. As we discussed before, you make the change and push it to a central repository on the server. And the server here is your master repository. And the client that you have will be in touch with the server, which will help you push and pull the code that you have or the changes that you have made. And the most important thing here is for you will be as a client server model. So a centralized workflow enables file locking so that any piece of code that's currently checked out will not be accessible to others. And what does it mean? It means that it will ensure that only one developer can contribute to the code at a given point of time. And there is also the use of branches that will help you check in or contribute to the central repository, which later on is merged. But let's not confuse you with these details for now. And you straight away push your commits or changes to the master repository. And as it's shown here, everything is centralized. And on the other hand, with DVCS or distributed version control, every single developer or team member has their own server. And they will have a copy of the entire history or version of the code. And the benefit of this is that the developer or user can work locally with the local repository and can be disconnected with what is going on in the remote server. And thus, you don't have to rely on the central repository all the time. And as I already told you, when we get the new changes from the repository, it is called pulling. And when we are merging the local changes or set of changes to the central repository, it is called pushing. So I hope it's clear. Let's move on. But still we have a confusion here that what is the difference between Git and GitHub? Because the session is for GitHub, so I'm talking about Git. So are they both different, or are they same, or are they being used together? So there are still more questions that we have not answered yet, but we will. So let's move on. So here is the thing. Listen to this very carefully. So Git that we discussed right now is the version control system. It's clear. And Git helps you manage and keep track of the source code history, like the changes, the commits, and the historical changes that you have made on your source code, which in other words is also called as versioning. And GitHub, on the other hand, is a cloud-based hosting service. Yes, it is a cloud-based hosting service that helps you manage the Git repositories remotely. So it helps you to manage the Git repositories that you have remotely, so that other users who are a part of your team can access the repositories and work on the code locally using Git. But with this definition, you might have understood that these two are surely different, but they work on similar principles. Git works with the local server repository management system, and GitHub is on the cloud that helps us to manage the repositories. But how do they interact, and how can we make use of GitHub with Git? I surely know that you might have doubts on this. Don't worry, keep watching. So as we know that Git is a DVCS or distributed version control system, and it was authored in 2005 while they were developing the Linux kernel. Git actually gives each developer a copy of the full development history. And that's one of the biggest advantages of using Git. And the next point is about branching. We will discuss this in some time. So the changes on Git are imported, and as well as you can create branches and commit your code, and later on you can merge the branch that you created onto the main branch. That you have the same way you can do it on your local repositories as well. So this is just a reflection of what you're doing on the remote server and what you're doing on the local server as well. So with branches, you can take your own path while you're coding by creating branches, and you can push your changes to that particular branch, and later on that branch changes can be merged to the main branch. And as I said already, the best part about Git is its local work usability and branching model. Let's check on the other side. Git, on the other hand, was developed as github.com. Remember that it is a cloud-based hosting service. So GitHub, on the other hand, was developed as github.com, and it started on October 19th, 2007. And the site was officially launched in the month of April 2008. And GitHub, unlike Git, is a cloud-based hosting service that lets you manage Git repositories. So the problem that we had on how to share the code with the team actually gets resolved here itself. And as this is a cloud-based hosting service, it has an online database that helps keep track of your projects outside of your local server or computer. So the problem is solved. And exclusively Git is only cloud-based. Now the first thing that we have here is we have to install Git, obviously. So let's suppose we have installed Git on our local computers and we are ready to use Git. And GitHub, being the moderator on the cloud, helps us manage our repositories. So the problem we had initially when we were discussing about sharing the code, committing the code, or even updating the code are resolved. Not completely, but for now, we can see a solution in place. That is Git and GitHub. Understand this very carefully. So GitHub is your cloud-based repository management service, and Git is your local repository management. And as you can see, each developer has its own Git server locally for them to work with. But how does a developer actually use Git? So let's go to that. So Sam is a developer working on an online shopping website and has Git installed on his machine locally. That is its local server versioning. The first thing he has to do post installing Git is to create a Git repository. A repository is a central location in which data is stored and managed in simple terms. And when it comes to version control, a repository is a data structure that stores metadata for a set of files or directory structure. Yes, you can store files and directories inside a repository. That should not be a surprise. And the repo, I'll use the short name for repository, and the repo will hold its metadata like when was it created, when was the change added, when was the code committed, or even when it was merged, and all the important pointers that actually cover the historical data that you have for your code. And we'll talk about that, don't worry. So here we will use the git commands to operate on Git locally. So using git init, we will create a Git repository, post which we add the files that we have for our source code, which becomes the first change set, and we add them to Git using git add command. And then we tell Git using the commit command that these are the changes that I want to be preserved. And along with the git command, you provide a message stating what exactly the change is about. And as a developer, we keep updating the code, and we also commit the change set. And every commit should have a commit message, and it will generate a unique hash value representing each of the commits that we have made. So every commit that we made will have its own hash value, which will be a pointer to that particular commit. And along with the commit, we'll pass on a commit message, which will show us what exactly the change is about, so that we can refer to that in later point of time. Just as you see here, think of this as a version of your code, or think of this as the versions of your code. And these are your historical changes. And remember that if you don't create a separate branch on Git, you can create a commit on the main branch itself, or else you can create a branch from the latest code, or even with a commit. Yes, you can create a branch from a commit, or else you can create a branch from the latest code, or even with a commit by using the commit hash that you see here. And later, once you have made your changes, it can be merged onto the master or the main branch. So let's suppose we have the branch name as dev. From the commit ID 44AE234448F8922, we have created the branch from that commit, and we have added our changes, and then we have merged it to the master branch. So now we have some idea on these topics, like why do we create repository, and what is its usage, what are commits, what is versioning, what is branching. But still, I know you might have doubts regarding them, so let's dig deeper into these topics. But before moving forward, now tell me, are you clear on what is Git and what does it mean when we say Git is an open source and distributed version control? I really hope you have, and if you still have doubts on them, please comment on your queries below on the comment section, and we'll surely discuss them as well. In a real world scenario, imagine we are working as a team on a web application or framework such as a library management system. So you will have your UI team working on the front end. You will have your dev team working on the integration and other development activities, alongside the DevOps team working along with the deployment. And we know that we need to work together, and even though we may not be working on the same files or features, the source code would be placed in the same location, that is our source code repository. And in that case, we might use the latest code, but we would want to separate ourselves from others by creating branches that would help us make our own changes and then push it to the master branch, which would then be held accountable for our release. For example, the UI team would create the feature branch called UI library management. Similarly, the dev team would create the one for themselves. And we might as well create branches of the code among others as well, if they wish to communicate or if they wish to contribute. And that's how we collaborate with teams as well. So I hope you got the point here. Let's move on.